Dear students, last class we learned about vitamins. In this recorded class, we will be discussing about steroids. This is your syllabus, and you can see you have to learn about steroids in this unit 6. An introduction, structure and functions of cholesterol, elementary idea of HDL and LDL, and bile acids. Please take your textbook. Please take the section steroids. So steroids, these are a type of organic compounds that contains a characteristic arrangement of 4 cycloalkane rings that are joined to each other. So these are a particular category of organic compounds which contain 4 cycloalkane rings. Cycloalkane means cyclic structures of alkanes. Okay, so they are having 4 cycloalkane rings, and these cycloalkane rings are joined to each other. And steroids are also called as sterols because many steroids are alcohols. That is, they contain OH groups. And where are they found? They are found in plants, animals and fungi. So all steroids are made in cells, and the most abundant steroid in animals is cholesterol. So we know that cholesterol, which is present in our body, is an example for a steroid. Other steroids hormones include estradiol and testosterone. Let us see a definition for a steroid. So you can see here, a steroid is defined as a compound which on selenium dehydrogenation form deals hydrocarbon, the structure of which is given below. So this is the structure of deals hydrocarbon. If we are heating any steroid in presence of selenium catalyst, dehydrogenation occurs. That is, the hydrogen molecules will be lost from the steroid ring structure, and this particular structure will be formed. This is the Diels hydrocarbon. In Diels hydrocarbon, you can see 4 cyclic ring structures. This 3 structure is actually benzene. 3 rings are actually benzene rings. Okay, and these are fused like this. So the name of this base structure is phenanthrene, and at the side of this phenanthrene ring there is a 5-membered ring structure fused together, and there is also a CH3 substituent on this 5-membered ring. So this is the structure of Diels hydrocarbon. The structure of steroids. The core of steroids is composed of carbon atoms bonded together that take the form of 4 fused rings, 3 cyclohexane rings which is designated as A, B and C, and 1 cyclopentane ring which is designated as D ring. So this is the base structure. We have a total of 4 rings. A, B and C is cyclohexane rings and D is cyclopentane ring. The steroids vary by the functional groups attached to this 4-ring core. Okay, so there can be different types of substituents or functional groups present in this core ring. It may be CH3, or it may be OH groups, or it may be a double bond. So different steroids vary in the functional groups or the positions of the functional groups in this core ring structure. Sterols are special forms of steroids with a hydroxyl group at position 3. So this particular group, sterol, it is characterized by an OH group at position 3. This is the position 3 of the core structure. You can see how the ring is numbered. So this is the order of numbering the ring, and this is the position 3. So in the case of sterols, all the steroids which belong to the class of sterols will have an OH group at position 3. They are derivatives of cyclopentano perhydrophenan 3. So sterols means they are derivatives of cyclopentano perhydrophenan 3. As we saw earlier, phenanthrene ring can be seen in the Diels hydrocarbon. Okay, so in this phenanthrene ring there is a cyclopentano ring attached, and in addition to that there will be a substitution of hydrogen molecules at all these double bonds. So in the case of steroids, these double bonds will be absent because all the double bonds are substituted by hydrogen molecules. Let us see an example of a sterol. This is a sterol and it is cholesterol. So this is found in our body. As you can see, there is no double bond, only one double bond at this position. All the other double bonds disappear. So that is how hydrogen substitution is done. So all the double bonds will be disappeared at this phenanthrene ring structure as a result of hydrogenation. And you can see that there is an OH group at the third position. Though the core structure is the same, that is a 4-membered ring structure which is 3 hexane rings and 1 cyclopentane ring, there is a difference in the functional groups or the positions of the functional groups and side chains in all these category of steroids. Now let us come back to this core structure of steroid. So many of them have secondary alcoholic groups. Secondary alcoholic group means they have an OH group which is attached to a carbon, which is in turn attached to 2 other carbon atoms. So in the case of cholesterol, the OH group at position 3 was a secondary alcoholic group and also contained 1 or more double bonds, carbon-carbon double bonds in ring A or B, and they have angular methyl groups at C10 and C13. So this is position 10 and position 13. So at these positions, that is at these carbon atoms, there will be methyl substituents in certain structures of steroids. So at these positions, since these are angular positions, we say that this is angular methyl groups at position C10 and C13. Classification of steroids. Steroids are classified as sex hormones, adrenal cortical hormones, cardiac glycosides and bile acids. So first we will learn the details of cholesterol. So cholesterol, as we said previously, it is the most abundant steroid present in animals and it is essential structural component of mammalian cell membranes. Cholesterol is the principal sterol synthesized by animals. In vertebrates, it is formed predominantly in the liver and it is present in all tissues of animals, especially in brain and spinal cord. Major dietary sources of cholesterol include cheese, egg yolk, beef, pork, poultry, fish and shrimp. Human breast milk also contains significant quantities of cholesterol, and cholesterol is not found in significant amounts in plant sources. So cholesterol is mainly present in animal mammalian cell membranes. It is present in brain and spinal cord, and it is predominantly formed in the liver, and it is synthesized by animals. And these are the major sources of cholesterol. Structure of cholesterol. Cholesterol is a derivative of cyclopentanoperhydrophenanthrin ring. So we can see the structure of cholesterol here. It is a derivative of phenanthrin ring, and most of the double bonds of the phenanthrin ring has been substituted by hydrogen molecule. Therefore, we call it as perhydrophenanthrin. And since there is a cyclopentano group attached to this perhydrophenanthrin ring, we call it as cyclopentanoperhydrophenanthrin ring. It is composed of carbon atoms bonded together that takes the form of 4 fused rings, that is 3 cyclohexane rings designated as rings A, B and C, and 1 cyclopentane ring designated as D ring. They have secondary alcoholic groups, that is CH-OH group at position 3, C3 position in the ring, and they contain 1 carbon-carbon double bond at 5-6 position. You can see that in the ring B there is a double bond present at 5-6 position, and also there is an OH group, that is a secondary alcoholic group, present at position 3. Here you can see that this carbon atom is bonded to 2 other carbon atoms, that is 2 and 4. Therefore, we call it as a secondary alcoholic group. And they also have angular methyl groups at C10 and C13. So, you can see the positions 10 and 13 here, and there are angular methyl groups, that is methyl groups in between this anchor. Okay, and 2 angular methyl groups are present in cholesterol. Also, there is a long alkyl chain starting from C17. Okay, so this is the structure of cholesterol. As a total, you can see that there are 27 carbon atoms present in this structure, and there is 1 OH group, 2 angular methyl groups, and also 1 carbon-carbon double bond. You have to learn this structure of cholesterol. Now let us see the functions of cholesterol. Cholesterol is required to build and maintain membranes. Then the second function is that for modulating membrane fluidity. Then it functions as functions in intracellular transport, cell signaling and nerve conduction, and it is converted to bile in the liver. You know that cholesterol is stored in the liver, so it is converted to bile and stored in the liver, and is an important precursor molecule for the synthesis of vitamin D and the steroid hormones. So vitamin D as well as many steroid hormones are synthesized from cholesterol. Therefore, it is also called as a precursor molecule. So precursor means something which is used for synthesizing another substance. So cholesterol is used for synthesizing vitamin D and steroid hormones. and it contributes to the development and working of the central nervous system, CNS, and it also acts as an antioxidant. So these are the important functions of cholesterol. Now let us learn about HDL and LDL. So there are two main types of cholesterol, which are HDL, that is good cholesterol, and LDL, that is bad cholesterol. So HDL, it is also called as high density lipoproteins. This is a short abbreviation for this HDL, high density lipoprotein. So HDL is called good cholesterol because it carries cholesterol from other parts of the body back to the liver, and the liver then removes the cholesterol from the body. So each bit of HDL cholesterol is a microscopic blob that consists of a rim of lipoprotein surrounding a cholesterol center. So this cholesterol center, a group of cholesterol molecules, is surrounded by a layer of lipoprotein. So these two together forms microscopic blobs. That is how HDL is occurring inside the human body. And the HDL cholesterol particle is dense compared to other types of cholesterol particles. Therefore, it is called as high density lipoprotein. So this is good cholesterol inside the body because it carries all the cholesterol from the various parts of the body back to the liver. That is, the liver then removes the cholesterol from the body. So let us see the good effects of HDL. HDL cholesterol reduces the risk of heart diseases in following ways. First is that HDL cholesterol scavenges and removes LDL cholesterol. So LDL means low density lipoprotein. That is, this lipoproteins will be having very low density. So HDL will scavenge on this LDL and it removes LDL from the body. LDL is dangerous to us. Therefore, HDL will remove LDL from the body. HDL reduces, reuses and recycles LDL cholesterol by transporting it to the liver where it can be reprocessed. HDL cholesterol prevents arteriosclerosis, which causes heart attacks and strokes, by scrubbing the inner walls of blood vessels clean and keeping it healthy. So HDL is called good cholesterol because it prevents conditions like arteriosclerosis. So arteriosclerosis causes heart attacks and strokes. So HDL cholesterol, it scrubs the inner walls of the blood vessels and it keeps it clean and healthy. It will scrub all the LDL which is deposited on the walls of the blood vessels, and it will make the blood flow more easy and smooth. So HDL cholesterol level greater than 60 milligrams per deciliter are high. So if in a body the HDL level is greater than 60 milligrams per deciliter, it means that the HDL cholesterol levels are very high, and HDL cholesterol level less than 40 milligrams per deciliter are low. So in general, people with high HDL are at a low risk of heart disease, and people with low HDL are at higher risk for heart disease. So So it is good that the HDL cholesterol level lies in between 40 and 60 inside our body. So increasing HDL levels. So changes in lifestyle may help to increase HDL levels. These changes may also help to prevent other diseases. Let us see the ways to increase HDL level in our body. First is eat a healthy diet. To raise the HDL level, saturated fats should be limited, and trans fats, which may be present in some margarines, fried foods and processed foods like baked goods, should be avoided. So we should avoid these things in our diet: saturated fats and trans fats which are present in fried foods and processed foods. Carbohydrates intake, especially sugar, should be controlled. Unsaturated fats, which are found in avocado, vegetable oils like olive oil and nuts, should be included in the diet. So our diet should include all these foods, that is avocado, then vegetable oils like olive oil and nuts, which has a major portion of unsaturated fats. Then foods which is naturally high in fiber content, such as oatmeal and beans, should be consumed. And stay at a healthy weight, that is HDL level can be boosted by losing weight. Then get regular exercise, and this will raise the HDL level as well as lower the LDL level. Then avoid cigarettes. Smoking and exposure to second-hand smoke can lower the HDL level. So therefore avoid cigarettes. Limit alcohol. Too much alcohol can lead to gaining weight, leading to lowering of HDL. So if HDL is lowered in the body, we have a higher risk for heart diseases. So limit alcohol. Then some cholesterol medicines can raise the HDL level in addition to lowering the LDL level. Now let us see more about LDL. LDL means low density lipoproteins. It is also called as bad cholesterol because a high LDL level leads to buildup of cholesterol in the arteries, and a high LDL level indicates that there is too much LDL cholesterol in the blood, and this extra LDL along with other substance forms plaque, and this plaque builds up in the arteries, leading to a condition called arteriosclerosis. That is, blocks are formed in our arteries. Coronary artery disease occurs when a plaque buildup is in the arteries of the heart, and it causes the arteries to become hardened and narrowed, which slows down or blocks the blood flow to the heart. So these are the effects of the high level of LDL proteins. So low density lipoprotein are dangerous to the proper functioning of the heart. So it will cause coronary artery diseases, and since blood carries oxygen to the heart, it may not be able to get enough oxygen if the arteries are blocked by this plaque buildup. So this can cause angina, that is chest pain, or if the blood flow is completely blocked, it can cause a heart attack. So what are the factors affecting LDL level? First is diet. Saturated fat and cholesterol in the consumed food that we eat make blood cholesterol level rise. Therefore, our diet should include a major portion of unsaturated fats. Then second factor is weight. Being overweight tends to raise the LDL level and lower the HDL level and increase the total cholesterol level. So total cholesterol means it is the sum of the HDL and LDL. So if our weight is overweight, it tends to increase the low density lipoprotein level in our body. As a result, the HDL level will also lower. Then physical activity. Lack of physical activity can lead to weight gain, as you know, and it can also rise the LDL level. Then smoking. Cigarette smoking lowers the HDL cholesterol. Since HDL helps to remove the LDL from the arteries, a lesser HDL level can contribute to a higher LDL level. Then the age and gender. As women and men get older, their cholesterol levels rise. So before the age of menopause, women have lower total cholesterol levels than men of the same age. But after the age of menopause, women's LDL level tends to rise. Okay, then next factor is genetics, that is, genes partly determine how much cholesterol body makes. For example, if certain people have certain genetic conditions like familial hypercholesterolemia, that is FH, and it is an inherited form of a high blood cholesterol. Okay, so genetical conditions can also determine the LDL level in addition to all other factors. Then medicines. Certain medicines including steroids, some blood pressure medicines and HIV/AIDS medicines can rise the LDL level of the body. If you are taking certain medicines like this for some other diseases, for cure of some other diseases, it can indirectly affect the LDL level also. Then other medical conditions, disease such as chronic kidney diseases, diabetes and HIV/AIDS can cause a higher LDL level. Then race, that is, certain human races may have an increased risk of high blood cholesterol. For example, African Americans, they typically have a higher HDL and LDL cholesterol levels than whites, that is the Europeans. Lowering of LDL cholesterol. So there are two main ways to lower the LDL cholesterol. First is a therapeutic lifestyle changes, that is TLC. So therapeutic lifestyle changes includes three parts. Heart healthy eating, that is, a heart healthy eating plan limits the amount of saturated and trans fats that we eat. Okay, so we have to choose a heart healthy eating lifestyle. Then weight management, that is, overweight person can lower the LDL cholesterol by losing weight, that is, by regular physical activity and all, they can manage their weight. Then physical activity, everyone should get regular physical activity. So these three factors contribute to a therapeutic lifestyle changes. Then second is drug treatment. So if lifestyle changes alone do not lower the cholesterol, medicine should be taken. So there are several types of cholesterol lowering drugs available, including statins. So the medicines work in different ways and can have different side effects. And some people with familial hypercholesterolemia (FH) condition may receive a treatment called lipoprotein apheresis. So this treatment uses a filtering medicine to remove LDL cholesterol from the blood, and then the machine returns rest of the blood back to the person. So in such cases this treatment is also used. So these are the major portions included in HDL and LDL. So this is a very important section for your exams. So now let us see about bile acids. So bile acids, so we previously mentioned that the cholesterol is being converted to bile and stored in the liver. So actually bile acids is a greenish yellow alkaline fluid produced by the liver and stored in the gallbladder, and bile contains bile acids, bile salts, cholesterol, bile pigments and lecithin. So all these substances are present in bile. So what are the substances? Bile acids, bile salts, cholesterol, bile pigments and lecithin. Then bile acids are steroid acids, that is, it has a carboxylic group attached to the core steroid structure. Then bile salts are bile acids accompanied with a cation, usually sodium. So the carboxylic groups H plus will be substituted by an Na plus ion. So in the case of bile salts. Then approximately 80% of all bile salts are the salts of derivatives of cholic acid, and adult human daily produces 400 to 800 ml of bile. So in the body of an adult human, daily 400 to 800 ml of bile will be produced by the liver. And what are the ingredients of this bile? There are bile acids, bile salts, cholesterols, bile pigments and lecithins. Let us see the functions of bile acids. So bile acids are critical for digestion and absorption of fats and fat soluble vitamins. Okay, so these are critical for digestion and absorption of fats in the body, and also for the absorption of fat soluble vitamins, and it thus aid in modulating cholesterol levels in the body. So the fats are insoluble in water, and bile acids will act as an emulsifying agent in the intestinal tract. Thus it will help to absorb the fat soluble vitamins. Okay, so fats are made soluble in the presence of bile acids so that they can be absorbed in the intestine. Now many waste products including excess cholesterol are eliminated from the body by secretion into bile and elimination in feces. So many waste products produced by the body, including the excess amount of cholesterol, these are eliminated from the body by secretion into bile and also into the feces. So the cholic acid and deoxycholic acids are the two important bile acids. So these are examples for bile acids, that is cholic acid and deoxycholic acids. So this is the end of this particular section, and next class we will learn about hormones. Thank you.